All right, here we go again on our own, going down the only road we've ever known on page 2. So, electronegativity. This is, the strict definition is the tendency of an atom to attract electrons or repel electrons. What do you think? Take a second to think about it in your head. And it's the tendency of an atom to attract electrons, okay? Which makes ionization energy the opposite. This is the tendency of an atom to lose electrons, okay? Valence electrons. These are the electrons in the innermost shell or the outermost shell. Think about it. And it's the electrons in the outermost shell. Just like your hands interact with the computer and everything around you in the world, and your feet carry you around, the outermost extremities of you are the things that interact with the everyday world. Atoms are really the same way. The outermost electrons are what participate in reactions and forming bonds and all these observable phenomena that we see atoms doing. Octet or duet rule is the rule that atoms require 2 or 8 electrons, depending on the shell. If it's the first shell, then it's 2. Everything else, it's 8 electrons to achieve stability. Okay, so if an electron, if an atom has 1 electron in its outer shell, then it's going to tend to lose that electron, so that the next electron shell below it will be the outer one, and it will have 8. If an atom has 7 electrons, it's going to tend to gain 1 electron so that it reaches 8. Okay? These two things really explain why atoms bond. So the most reactive metal, and this is really important. I really suggest that you get this in your head, because if you know the most reactive metal and the most reactive non-metal, then you can use that information to remember all of the trends. In fact, I'm just going to add one extra bonus definition here, which is atomic radius. I assume you guys know this, but if you don't, atomic radius is simply the size of an atom, right? It's the distance from the center to the outermost edge. So going back to number 10, the most reactive metal is going to be all the way down at the bottom and at the left. And I showed a video on it. We talked about this. It is cesium, right? Most reactive metal. Why is it the most reactive? Well, it's because you have to remember the trends. So it has a very low ionization energy. By the way, it also has a very low electronegativity, and it is a very large atom. I say this because you can remember the trends. Why does it have low ionization or low electronegativity, and why is it a large atom? It's because these trends are all governed by one principle, Coulomb's law, okay? Coulomb's law being the law that states that opposites will attract and like will repel, okay? So if you have more protons in the center of an atom, those protons are going to attract negatively charged electrons. So as you add protons going from left to right, atoms are going to get smaller. They are going to attract electrons more because there are more protons. Okay, it's like having a stronger and stronger magnet. And they're going to have a lower ionization energy because they're holding on to their electrons so strongly that they don't really want to lose electrons, which is what ionization energy is. It's the energy to lose electrons. So that tells us that cesium is the opposite of our trend, because as we're going down, we're adding more and more electron shells, and each of those electron shells is having a repelling effect on the outermost electrons. It's a phenomenon we refer to as electron shielding, where the electrons in the shells shield the protons that are in the center that would otherwise attract the outermost electron. So it's because cesium has a very low ionization energy. It will lose electrons. And remember, cesium has one electron in its outer shell, and it tends to lose that electron to something that's over here, which clues us into the next answer. Okay? The most reactive nonmetal is going to be the exact opposite. It's going to be all the way up and to the right. Fluorine. Okay? So fluorine is the most reactive metal, or nonmetal, I should say. Why? It has a high electronegativity, high ionization energy, and also it's very small. Okay. So fluorine, chemical symbol F. Now, it's the most reactive because we added more and more and more protons, right? As we went from left to right in the periodic table, we're adding more and more protons, which is going to attract more electrons, right? Fluorine has an attractive influence on electrons. And what we do is we go up the periodic table as we have less and less of those electron shells that would have a shielding effect. So at this point, we only have 2 shells. There's very little shielding effect where electrons repel other electrons. So fluorine, most reactive because it has the highest electronegativity. Cesium has the lowest ionization energy. If you can memorize these two, what's nice about them is that they will help you remember all of the trends, okay? So if you're asked to compare, say, nitrogen and fluorine and say which is more electronegative, you'd say, well, electronegativity increases as I go up and to the right. So fluorine must be more electronegative than nitrogen, and it also must be more electronegative than chlorine. Okay, very useful tool. I would recommend maybe even writing this down on your periodic table. Okay, so to recap, fluorine is the most reactive because it has fluorine has a high electronegativity. Okay. 12. What happens to electronegativity and ionization as you move from left to right? We just talked about that. As you go from left to right, you add more protons without adding electron shells, so it increases. What happens to electronegativity and ionization energy as you move from the top to bottom of a periodic table? Well, as you go down, you're adding an electron shell each time, okay? And as you add those electron shells, they have a shielding effect because each shell has electrons, and those electrons repel the outer electrons, right? They push the outer electrons away. So that means the atom isn't going to attract electrons very well, and it's going to lose electrons more easy. So as you go down, you're adding more electron shells. So ionization energy and electronegativity decrease. What happens to atomic radius as you move from the top to the bottom of the periodic table? Well, if this is small and this is large, then as you go down, atomic radius increases. Why are valence electrons so important? Again, these are on the outer shell of electrons, right? This is the valence electron. And we talked about just how your hands and your feet interact mostly with the outside world. That's how atoms work too. So valence electrons participate in bonding. It's really just that simple. Okay? All right, so number 16, circle the atom in each pair that has the greater electronegativity. So we're going to use what we just talked about and apply it to this situation. So calcium or gallium? Well, you guys can see that calcium is here, gallium is over here. Electronegativity increases in this direction. So the more electronegative would be gallium. Bromine or astatine? Bromine is here, astatine is here. Bromine is further to the right, so it would be bromine. Okay, lithium or oxygen? Lithium's here, oxygen's here. Oxygen is further to the right, okay. So it's going to be oxygen. Barium or strontium? Barium is here, strontium is here. Strontium is further up. Just a second. So that would be the correct answer, strontium. Chlorine or sulfur? Chlorine and sulfur are here. Chlorine is further to the right, so it's chlorine. Oxygen and sulfur. Oxygen is further up, so it's more electronegative. All right, we'll pick it back up in the next video.